Welcome to this short video where we will work through how VLab can be used to construct complex test environments such as a closed-loop simulation of a synchronous three-phase motor system. The test environment that we will be using starts at the board level, into which we instantiate an RH850 virtual platform. Loaded onto the platform are various layers of software, starting with the application layer and working its way down to drivers. Within the RH850, we instantiate a number of peripheral models, including timers, both general and for PWM, interrupt controllers, GPIO, analog-to-digital converters, and finally RDC. To complete the board, the simulation instantiates ASIC components such as the inverter, chopper, and current sensors. Outside of the board, our environment drives and then receives feedback from the motor model, along with a resolver that tracks the angle of the drive shaft after a mechanical load has been applied. In the demonstrations that are to follow, you will see a number of simulation scenarios, each of which produces output in the form of plots that can be used for analysis and represents many of the key connections that can now be seen on screen. The first scenario, which is now on screen, plots the value of software variables as seen at the register level inside the MCU. The first three plots are the values programmed at the registers for the PWM timer peripheral. The next two plots are the U and V current values as measured from the ADC peripheral conversion register. Next, you can see the value returned from the RDC peripheral angle register representing the angle of the drive shaft, which periodically drops to 0 as the shaft completes a full revolution. Finally, we can see the speed as calculated by the motor model, which is slowly accelerating. If we now switch over to the system pane, the internals of the motor model along with the RH850 virtual platform and ASIC models are available for introspection, most of which can not be accessed when working with real hardware. To further demonstrate the level of access available to VLab users when using virtual environments, I am now showing two simulation runs which plot both calculated and actual current and voltage values over time. The final scenario to be demonstrated highlights one of the most valuable features of working in a virtual environment. In the scenario now executing, a normal operation occurs until a fault is injected after 50 milliseconds, where the output of the U current sensor is forced to a constant value. As a consequence, the motor reverses direction at very high velocity, which can clearly be seen in the plots. With real hardware, such a sequence of events would most likely cause a catastrophic failure and damage to equipment. Thank you for taking the time to watch this demonstration. If you can picture VLab being part of your development and testing environments, then please contact us through sales@vlabworks.com.